Automated Plant Grid, a new effortless solution to growing plants at home. Objectives. Our system has three main objectives. Firstly, the system should be able to tell when each plant needs water depending on the plant's water level and the type of plant selected through the interface. Secondly, the system should provide an adjustable daily light cycle via controllable LEDs. Thirdly, the system should be able to detect if one of the plants dies and informs you via text message. Sensing mechanisms. Our system will be using two sensors. Firstly, we will be using a resistor type force sensor, which has two substrate layers, the conductive film and the plastic spacer, which has openings aligned with the conductive layer. When a force is applied to the sensor, the conductive film deforms against the substrate. The more of the ink touching the substrate film, the higher the resistance, which will output a lower voltage. Secondly, we will be using a flow meter. This sensor uses a Hall effect sensor along with an internal rotor with a magnetized blade. The flow of the water will cause the blades to rotate, and every time one passes over the Hall effect sensor, it will detect the magnetic field and output a signal. This frequency is proportional to the measured flow rate. Constant K is used to correlate the number of pulses to the flow rate. Building blocks. 1. The 4 force sensors under each pot will sense the weight of each pot. 2. The flow meter will measure how much water is outputted to the plants. 3. The transducer will convert resistance to voltage. 4. The amplifier will condition the signals. 5. The signals will be read by the DAQ system, which is passed on to LabVIEW. 6. Using coding, LabVIEW will convert voltages from the force sensor connected to the transducer to mass and compare it to the required mass, i.e. mass with water. 7. Using coding, LabVIEW will convert voltage from the flow meter to volumetric flow rate and compare it to the required volume and hence required time for the water to reach that volume. 8. The output signal, time for the required volume, is sent to the controller which waters the plants using a pump and water reservoir. Potential applications. The applications of our project are numerous. Farmers and people with plants who forget to water them can use our system to maintain plants with much less upkeep, allowing them to put more time into crops or animals that need extra attention. They can also grow more plants at the same time because they don't need to spend as much time on every plant. This is also very applicable to pet care, as the part of our design that senses when more water needs to be added could be easily adapted to sense when an animal's food is getting low and refill it, or be set to refill the food at a certain time. The water bowl wouldn't even require a change in the code. Thank you for listening.